Okay, so let us discuss 14.29 today. It is said that in a certain factory, there are two different processes of manufacturing the same item. So from the first line itself, we can get a hint that this is talking about two different samples. Okay. So either it will be a test of equality of two proportions or test of equality of two means. Okay. Either of these two, the test we will have to select. So the first line says in a certain factory there are two processes. Okay. So and then it says the average weight in a sample of 250 items produced from one process is found to be 120 grams. So here it is the second line is talking about the first sample where there are 250 items. So first is N1, that is sample size of the first sample is 250. Okay, and the average weight, that means this is the mean. This is the mean of the first sample, which is 120 grams with a SD of 12 grams. That means standard deviation of 12 grams. You all know by now, if you have gone through the recording and those who have attended the classes, they will know that for testing with the help of means, we need information about the mean as well as the standard deviation, right? So here it is given in the second line. It talks about the first sample. It says the sample size is 250 and the average weight, that is the mean of the first sample, is 120 and standard deviation of 12 grams, that is SD. Sigma is 12 grams, is 12. Okay, and the corresponding figures in a sample of 400 items from the other process is 124 and 4. So the next line says about the second sample whose size is 400 and it has a mean weight of 124 and standard deviation of 4. Okay, then we are supposed to compute the standard error of difference between the two sample means, that is SE. We will calculate, is this difference significant? That if this line says that we have to test. Also find 99% confidence limits for the difference in the average weight of items produced by the two processes. Okay, so this last three lines says first we will calculate sample error or standard error, which we have to calculate if we want to test. If we want to apply any test, Z test, T test, whichever test, we have to calculate the standard error. So we will calculate that. Then after that we will test the null and the alternative null hypothesis we will test, and then the 99% confidence limits has been asked to be tested. That means we have to consider 1% level of significance. Okay, so let us start. If you don't write the question now, no need to write it now. You can write it after the class also. But solve the problem. Do write the solution in your copy. No need to write the question now. Write the solution. Okay. So from the information given in the question, it is clear that it is the sum of the testing of equality of two means with the help of Z test, because the sample sizes are more than 30. Okay. So let us start. First we will write the null and the alternative hypothesis, then we will solve. So write down please. Null hypothesis is that, write down, null hypothesis is that the average weights of items, null hypothesis is that the average heights of the items produced from the two processes are equal. Produced from the two processes are equal. Are equal. And alternative hypothesis is that And alternative hypothesis is that the averages are not equal. The averages are not equal. Then you will write in the next line H naught. In the next line you will write H naught in bracket mu1 equals to mu2. It will be mu1 equals to mu2. Okay. So H naught in bracket you will write mu1 equals to mu2. Then you write H1, that is the alternative hypothesis. H1 in bracket you will write mu1 not equals to mu2. Mu1 not equals to mu2. Mu1 not equals to mu2. So H naught is mu1 equals to mu2 and H1 is mu1 not equals to mu2. Then you write this information. Sample sizes. You write down sample sizes. Sample sizes, you write N1 equals to 250, N2 equals to 400. N1 equals to 250 and N2 equals to 400. Then sample means, write down sample means. We notify sample means by X bars, right? So here also we write it as X1 bar equals to 120 and X2 bar equals to 124. Sample means X1 bar equals to 120 and X2 bar equals to 124. Then sample SDs, that is standard deviations. Sample SD, S1 equals to 12, S2 equals to 14. This will be 14. I think in the question it is mentioned 4. It will be 14, okay? So sample SDs, S1 equals to 12 and S2 equals to 14. Okay. So we have noted down noted down the things as per our information given in the question. Next you write, since the population SDs are not known, this line you will have to write, okay? Whenever in the population informations are not given, then you will have to write this line and then you will have to replace sigma 1 and sigma 2 by x1 and x2. Okay, so write down since the population SDs are not known, since the population SDs are not known, comma, we use the sample SDs to calculate the standard error. We use the sample SDs to calculate the standard error of the difference, standard error of the difference x1 bar minus x2 bar. So we use the sample SDs to calculate the standard error of the difference x1 bar minus x2 bar. In bracket you will write this between the two sample means. Between the two sample means. So we substitute this formula, okay? This if you have written the formula, it will be in your copy, and it is in this file also. So it is the formula of SE of x1 bar minus x2 bar equals to, write down the formula from your screen, please. SE of x1 bar minus x2 bar equals to, put a root over, put a big root over, and under the root over you write S1 square. Charge খুলছিস কেন? এখানে খুলছিস কেন? Written this formula, under root over you write S1 square by N1 plus S2 square by N2. That is equals to, under root over you will write, you will replace S1 by 12 and S2 by 14. Just write down 12 square by 250 plus 14 square by 400. So what will you do? First you will make 12 square and see how much it is. 12 square means 12 into 12. So you will see this in your calculator, and the number which you will get, you will divide that by 250 plus 14 square you will do. After that you will divide that number by 400. Then you will add these two numbers. You will get a number. And then finally you will find the root over of this final number. Tell me whether you're getting this answer or not. 1.03 or not? Tell me. Okay. Okay, thank you, Rina. It is 1.032. You can round it to 1.03 also, no problem. Okay, so then now we know the value of standard error of x1 bar minus x2 bar. Let us calculate the value of the test statistic. So write down that value, don't write observed, right? The value of the test statistic is, the value of the test statistic is z equals to, the value of the test statistic is z equals to, so this is a formula again. You need to use the right formula, okay? You don't have to memorize it this time because you will be able to write it by seeing. That means assignment based exams will happen, but make sure that you are using the right formula in the right sum. Okay, so write down z equals to x1 bar minus x2 bar x1 bar minus x2 bar divided by SE. Okay. So write down x1 bar as 120 and x2 bar, substitute x2 bar with 124, and in the denominator it will be SE or standard error, which will be 1.03. Right now you have calculated the value of standard error, so it will be 1.03. If you solve it, you will get minus 3.9. Okay. Now this type of thing we have also done in the previous day. Since this is a test of equality of two means, then we need to ignore the minus sign, because whenever we are doing the test of equality of two means or two proportions, whatever, then, or if it is if it is of single mean and single proportion also, but your null is equals to and alternative is not equals to, then you have to ignore the minus sign in the Z statistic if you get any, because here we don't take Z only, but we take mods of Z. Mod of Z we take, okay? And since mod we are taking, that's why all minus sign becomes positive, because mod means no value can come in negative or in fraction. Mod means all the values will be, no, sorry, not in fraction. No, mod means no value can be taken as a negative one. Mod means all the values will have to be taken as positive. That's why, okay? I hope you have listened to me carefully. In the previous class also I told this, that whenever you're doing the first type, the problem of the first type, that means equals to and not equals to, then you have to ignore the minus sign if you get any in the calculation of the Z statistic. Okay. So here you are getting minus 3.9. So here we will ignore the minus sign. We will only consider 3.9. Okay. Since then we will write is it at, you will write the lines whichever you can see on your screen. Okay. These lines are all important. So please write down critical region, for both sided alternatives, critical region for both sided alternatives, h1 under bracket mu1 not equals to mu2. We are writing it in the form of h1. You can also write it as directly of h0. Okay. Critical region for both sided alternatives, that is h1, mu1 not equals to mu2 is, mu1 not equals to mu2 is z greater than equals to 2.58. We will not write about 1.96 because in the question we were asked to test at 1%. So no need to write about 5% here. Okay. So you will write critical region for both sided alternatives, that is not equals to h1 mu1 not equals to mu2 bracket close is mod z greater or equals to 2.58. You will write mod z greater or equals to 2.58 at 1% level of significance. At 1% level of significance. So now first you will write about the critical region. What is the critical region? Then you will write about why you are accepting or rejecting. Okay. So next line you write, since mod z equals to 3.9, since mod z equals to 3.9 exceeds 2.58, comma, we reject h naught. Just a minute. Huh? Okay, so what did you write? You will write, since mod z equals to 3.9 exceeds 2.58, comma, we reject h naught at 1% level of significance. We reject h naught at 1% level of significance and conclude that the difference between two means is significant, and conclude that the difference between two means is significant. Significant means there is difference. Okay, the assumption that there is no difference is incorrect. Therefore, we need to conclude that the difference between the two means is significant. That is, mu1 not equals to mu2. Since we are rejecting h naught, so we will accept h1. Since we are rejecting h naught, so we will have to accept h1. And since we are accepting h1, that means we are concluding that the difference between two means is significant. And if you are asked to calculate confidence limits, then you will calculate it. I hope I have given you the formula of calculating confidence limits. Let me see once. Yes, confidence limits formula are there. So if you are asked, you are not asked in this question, okay? If you are asked, then you can use the formula of calculating the confidence limits at 5% or 1%, whichever will be given to you, whichever will be asked to you will use that formula and calculate. Okay. This portion is not required, 99% confidence limits, because it is not asked in this question. All right. Any doubt? Any doubt in this problem which we have solved right now? Any doubt? Anyone? You can ask. Any doubt? Okay, I believe
Um,
no doubt. Okay, fine. All right, so two more sums are left in Z test. We'll do this tomorrow. And after that, I'll give you certain exercise problems. You will practice those problems, okay? And while practicing, whichever doubt you're getting, you will contact me through WhatsApp message and I will clear your doubt, okay? So tomorrow we'll finish off this Z test and day after tomorrow we'll start the T test, okay? And t-test also there will be 4 types, so we will have to take some time to calculate. Maybe next week we will be able to complete t-test also. Okay, so please attend the classes for these days at least, because learning the test is important. Theory you can write on your own, but test you will not be able to do on your own. Okay, so please attend the classes so that you understand. So those who are listening to the recording, those who are attending classes, to everyone I am saying this. Okay, your attendance is given. I have given your attendance. So you can leave the meet. See you tomorrow. And tomorrow I'll finish up the Z test. Okay, bye bye.
Thank you, ma'am.
Thank you.